All right, section 3, what we're going to do is we're going to run into what's called the number E. E is a special irrational number that we encounter in a lot of different situations in nature, also in banking. You'll see it in the example we're going to get to in a second. But how E comes about is, if you notice, it's 1, and then what they do is they add another 1, but what they do is they create that by putting a denominator of 1. And then my numerators all stay the same, always 1. But each time my denominator, we multiply by the next integer. So 1, then 1 times 2, then 1 times 2, 1 times 2 times 3, so on and so forth. What we end up getting is approximately 2.718. Now, that is on your calculator. Okay? And if you want to look at it, and we'll get into this more eventually when we start talking about our logarithms, but this button right here, ln, stands for natural log. And I know you can't see it on this one probably, but that's e to the x down here. And so it's a second function. So what we have to do is hit second natural log, and what that will do is bring up the e. Okay, so second natural log. It's asking you to put some value in when it has parentheses. Okay, if I just hit enter, it's going to give me an error. So anytime there's those parentheses, you have to put something in there. So if we put in 1, okay, because e to the first is just e, there's your 2.718, blah, blah, blah. Okay. So a very common situation that we run into where we use the value e in this formula is when we compound interest continuously. Okay, in 11.2 we talked about compounding in different intervals. Okay, could be quarterly, could be yearly, so on and so forth. Compound continuously means it's always adding to the account. Okay, so I just added money to my account, just added money to my account, just added money to my account. Okay, constantly. Okay, it's so small though that you'll never notice it. So these values mean pretty much the same thing. This is what we end up with, A. P again talks about your principal, or what we're going to start with in that account. E again is that special irrational number. R, still my interest rate as a decimal. And then T again, going to be your time in years that we leave the money in the account. Okay. This one, you know, it's really difficult to actually use a y equal a plus bx because of the fact that e is involved. And a lot of times this is called your PERT formula. So what we do is we recognize the compounded continuously. Oh, that means I need to use PERT. Okay. So when I read through this example, Hunter decides he has $3,000 to invest. He puts it into an account that earns 1.75% interest compounded continuously. As soon as I see that compounded continuously, that tells me that I need to use that PERT formula. Okay, so one thing that I didn't mention probably in the last one is always write down the formula you're going to use. Okay, that way you're plugging numbers in the correct spot. So first thing, we got $3,000 to invest. That means I got $3,000 to start with. Okay, my E is always going to be there. 1.75% interest. Again, 1.75 per 100, 0.0175. Like I said, that's a very dangerous spot because people often goof up their interest rate. Okay, if we leave the money in there for 8 years, okay, how much will I end up with? And again, this is very easy to type this into your calculator. Okay, we got 3,000. I need to bring up that E. Now, the nice thing, the parentheses are already there, so I can just type in 0.0175 times 8 and done. So 3450 and 82 cents, because again, dealing with money, we want to go to 2 decimal places. Okay, so in those 8 years, he makes about $450 on that. All right. So another situation, very similar. Again, Hunter, he's got that same amount of money, same account, but he wants to know how long it's going to take until he gets $5,000 out of that. Okay. But again, because I see compounded continuously, I know I'm using PERT. Difference here is I want to end with 5,000. I'm starting with 3,000. My interest rate is still there. Now, if we run into this situation, you don't know how to solve it yet. Okay, I just wanted to set this up to kind of preview what we're going to get into when we start dealing with logarithms. The logarithms, again, are going to be what allows me to bring that variable, that t, out of the exponent. Okay, so if you run into a problem like this in the homework, you probably made a mistake because of the fact that we haven't gotten that point yet. So good luck with this section. Again, it's just formulas, plug the numbers in, hit the buttons on your calculator, get your solution. Always make sure your solutions make sense. Obviously, if I go back here and Hunter has those $3,000 and in 8 years it becomes $10,000, I either want to find that bank account or can you find that bank so I can put money into it, or you did something wrong. All right, good luck.